Welcome, geometry students, to the homework help video, page 451, 9 through 20, and 31 through 36. Let's go ahead and get started with the help video. Let me turn over to page 451 here. Give me just a second, and here we go. Alright, numbers 9 through 16. The directions say to find the value of each variable in radical form. Okay, so here we go. Let's take a look first of all at number 9. Notice we have a 30, 60, 90 triangle. Okay, and so remember what I've said to you before about 30, 60, 90 triangles. It really helps to know the shortest leg first, and if you know the shortest leg, then you can automatically, in this case we do, because the smallest side is 30, so go straight across. Number 12 has to be the shortest leg. The shortest leg will always be across from 30 degrees in a 30, 60, 90 triangle. Okay, so remember, when you know the shorter leg, you multiply it by 2, and that will always give you the hypotenuse. So b equals 24. It's that easy. Now, take the shorter leg and always multiply it by the square root of 3, and that will give you the longer leg. So the longer leg would be 12 square root of 3. And that's it, guys. That's all you got to do. Okay? So A is 12 square root of 3, and B is 24. Listen, guys, in a 30, 60, 90 triangle, once you know the shorter leg, everything else really falls into place. Okay? Alright, number 10. This is a 30, 60, 90 triangle. Notice we do not know the shorter leg, which is okay, but I do know the hypotenuse. And remember, guys, the shorter leg, the hypotenuse, is always twice as big as the shorter leg. Okay? So, if that's the case, then I can divide this in half, and I know C equals 5. Okay, because the hypotenuse is always twice as big as the shorter leg, so C is 5. Now, once I know the shorter leg, remember, I just take the shorter leg and I multiply it by the square root of 3, and that'll be the distance of my longer leg. Okay, so let's see if I'm right on this. C is 5, and D is 5 square root of 3. Really simple, guys. Number 11, we have a 45, 45, 90 triangle. Okay, and remember, when dealing with 45, 45, 90 triangles, the legs are always congruent. So if this leg is 2, then this leg over here has to be 2. Okay, and then the hypotenuse is always, you always take the leg and multiply it by the square root of 2, and that will give you the hypotenuse. So the leg is 2, multiply that by square root of 2, and the hypotenuse is 2 square root of 2. Okay, pretty simple. So the legs are congruent, and the hypotenuse is always square root of 2 times the leg. Alright, once again, we have a 45, 45, 90 degree triangle. So, I do not know either one of my legs. Okay, so, I take my hypotenuse. Now remember, guys, think about it. My shorter leg, I always take my shorter leg and I multiply it by what? Square root of 2 to get the hypotenuse. So, in this case, I'm going to take my hypotenuse and I'm going to divide it by square root of 2, and then it should give my leg to me. Okay, so my leg over here is going to be 9 divided by square root of 2, which means this leg here is also 9 divided by square root of 2. Think about it, guys. It makes total sense. If I give you a leg, you multiply it by square root of 2 to get the hypotenuse. If I give you the hypotenuse, then you divide it by square root of 2 to give me the shorter leg, to give me the leg. Okay, so 9 divided by square root of 2 for my legs. Alright, number 13. Now, guys, think about this. If this is 60 and this is 60, that means this whole angle up here is also 60. Okay, and if I've got a right angle here, and they're sharing a common side, I've got angle, angle side, angle side, guys. These two little triangles are congruent. So when I cut 60 in half up here, I really have 30 degrees right here. Okay, so what I have is a 30, 60, 90 triangle right here. Okay, right there it is. 30, 60, 90 triangle right there. Okay, so here we go. My hypotenuse is 12. Now remember, in a 30, 60, 90 triangle, the hypotenuse is always twice as big as the shorter leg. So here's 30, go straight across. K is my shorter leg, so K will be 6, half of the hypotenuse. Now my longer leg, j, you always take the shorter leg and multiply it by the square root of 3. So j is going to be 6 square root of 3. And there it is. Okay? Alright, number 14. Now, let's think this through here for a second. I know this is 60. I know this is 90. So I know this has to be 30 right here. Okay? We're looking for the length of L and M. So if you'll completely ignore this up here, I have a nice 30, 60, 90 triangle right down here. That's what I'm going to use, okay? So here we go. Notice 30 is my smaller angle. Go straight across. Look, I know my shorter side. When I know my shorter side, it makes the 30, 60, 90 triangle so easy. You take your shorter side, multiply it by 2, and that gives you the length of the hypotenuse. So M would be 12. And then you take your shorter leg and you multiply it by square root of 3, and that gives you the length of your longer leg, which is L. So there we go, guys. There it is. 6 square root of 3 and 12. Alright, number 15. Well, let's see what we've got here. This is 45 degrees here, and this is 45 degrees right here, okay? So I have a 45, 45, 90 triangle right here. And I know that because 45 plus 45 plus 90 is 180, okay? So forget the rest of this triangle. I know this hypotenuse right here is 6 square root of 2. I'm going to go ahead and write this triangle over here to see it better. So there's my 45, 45, 90 triangle. My hypotenuse is 6 square root of 2. So remember, if you know the leg in a 45, 45, 90 triangle, you multiply it by the square root of 2. However, if you know the hypotenuse, you divide it by the square root of 2. So 6 square root of 2 divided by the square root of 2. These will cancel out, leaving you with 6. So I took my hypotenuse, I divided it by the square root of 2, and I got 6. Remember, in a 45, 45, 90 triangle, the legs are congruent, so both of these sides will be 6. So N and N are both going to be 6, okay? Alright, moving on to number 16. Okay, now we have a 45, 45, 90 triangle again, students, right here. Okay, these are pretty redundant, alright? Now look. One of my legs is 16, so I know my other leg is 16. And then anytime you know the leg of a 45, 45, 90 triangle, you multiply the leg by the square root of 2, and that will give you the hypotenuse. So Q equals 16 times the square root of 2, and P equals 16. There we go. Alright, moving on now to number 17, 18, 19, and 20, okay? Starting with 17, what is the length of an altitude of an equilateral triangle whose sides have lengths of 12 square root of 2? So let me get a drink here. And we're going to draw an altitude of an equilateral triangle. So here's my equilateral triangle. That's 60, 60, 60, okay? We're going to draw the altitude right here. And of course the altitude is going to be 90. And we have 60 here and 60 here. And that's going to cut this top angle in half, 30. And the sides of the equilateral triangle would be 12 square root of 2. So there we go, 12 square root of 2. Now, I'm going to glance at the answer. I'm not sure what form they want it to be in. Okay, alright, that makes sense. Now, here's what we have, students, okay? Please look carefully. What is the length of the altitude? So they want us to find this line right here. The length of the altitude. I'm going to call that X. And we really don't need this part of the triangle over here whatsoever. We don't need that at all. If we're looking for X, all that we need to know is we have a really nice 30, 60, 90 triangle, okay? Now, this is called your hypotenuse, okay? Remember, the hypotenuse is always twice as big as your shorter leg. So I'm going to take this and divide it by 2. So 12 square root of 2 divided by 2. These numbers here cancel, and you're left with 6 square root of 2. You do not divide the inside number here by the 2. That is incorrect to do, okay? So, what I'm left with, if my hypotenuse is 12 square root of 2, then my shorter leg, which is always across from the 30, is going to be square root of 2. And now, how do you get the longer leg, which is your altitude? It's across from the 60. How do you get your longer leg? Remember, you always multiply this by the square root of 3. So I have the square root of 2 times the square root of 3, which would be the square root of 6. And that is the answer. Listen, students, anytime you have a 30, 60, 90 triangle, once you know the shorter side, everything else really falls into place. Number 18, what is the length of a side of an equilateral triangle whose altitude is 21? So once again, I'm going to draw my equilateral triangle, okay? 60, 60, 60. Then I'm going to draw my altitude, alright? Put a right angle here, and the altitude is 21. Now I'm going to take my pen here, and I'm going to get rid of this triangle over here, because I do not need this part of the triangle at all. It was an equilateral triangle, but I cut it in half, and I know this is 60, and I know this is 30, and I know my altitude is 21. What is the length of the side of the equilateral triangle? Now if I put my equilateral triangle back up here like this, the side would be this length right here. So that's what I'm looking for. So I'm going to put X right here. Now, we know this longer side right here is, we know the longer leg is 21, okay? Now remember, if you know the shorter leg, you multiply it by the square root of 3 to get this. We're going backwards, so we're going to take 21 and divide it by the square root of 3. And that's how you would get the shorter leg. I hope that makes sense. Let's go over that again. If I give you the shorter leg, you multiply it by the square root of 3 to get the longer leg. Well, if I give the longer leg, then divide the longer leg by the square root of 3, and that will give you the shorter leg. Okay? Now, in order to get this length right here, which of course is the hypotenuse, right across from 90, you have to take this and multiply it by 2. So 21 over the square root of 3 times 2 over 1 would give you 42 over the square root of 3, okay? Because 21 times 2 is 42, and square root of 3 times 1 is square root of 3. So 42 over square root of 3. Now, I'm trying to think. Okay, so this is where it gets frustrating, guys, because earlier in a problem I looked in the book, and they did not make you rationalize the denominator. So I'm going to go back and show you that problem, okay? Back here, number 12, even though you can't see the answer, in my teacher's edition book, they had 9 over square root of 2. Yet in algebra 2, you should have learned, hopefully algebra 1 too, to multiply the top and the bottom by the square root of 2, which gives you 9 square root of 2 over square root of 2 times square root of 2 is square root of 4, which is 2. Okay? Now don't worry, do not worry one little bit. If you did not understand what I did, I will teach you that later if we have to do it. But here, back here, they allowed you to have 9 over square root of 2. Then this problem here, they want you to not have the square root in the denominator. So I'm okay with this answer here for now. 42 over square root of 3 is fine, okay? Alright, moving on. And this is fine also for those who rationalized the denominator. Alright, number 19. The perimeter of a square is 24. Find the length of the diagonal. Okay, here's my square. Okay, 90 degrees. Here's my diagonal. That's my x. Now, the perimeter is 24. That means each side of the square is 4. Okay, so I have a right triangle up here. I'm going to go ahead and get rid of this. I have a right triangle with sides of 6 and 6. Now, remember what that means, guys, okay? That means we have a 45, 45, 90 triangle. How do I know that? Because whenever two sides of a triangle are congruent, their opposite angles are congruent. So that means these two angles here have to be congruent. So they have to be 45 and 45, because 45 plus 45 plus 90 is 180. Okay? So I'm looking for my x right here. Well, guys, we know what to do. We have a 45, 45, 90 triangle. And anytime you have a 45, excuse me for yawning, a 45, 45, 90 triangle, you take one of the legs and multiply it by the square root of 2. So the hypotenuse or the diagonal of the square will be 6 times the square root of 2. Okay, 6 times the square root of 2. Alright, number 20. The length of the diagonal of a square is 18. What is the length of each side? Okay, no problem. So I know again I've got a square. I draw my diagonal. I know I've got a 90 degrees here, 45 here, 45 here. So the length of the diagonal is 18. So find the length of each side. Well, guys, I've got a right triangle right here. Do you see that? And it's a 45, 45, 90 right triangle. So anytime you're given the hypotenuse, you take the hypotenuse and you divide it by the square root of 2. Okay? And so when you do that, you're going to get this right here for an answer. Now again, it's kind of frustrating. This is totally acceptable. I have no problem with that. What they did is they took 18 over square root of 2, and because they had a square root of 2 in the denominator, they multiplied the top and the bottom of the fraction by square root of 2. 18 times square root of 2 is 18. Square root of 2. Square root of 2 times square root of 2 is going to be the square root of 4, which is 2. And then your 2 cancels out your 18 9 times, and you're left with 9 square root of 2. I am totally fine with this answer over here, but I'm going to keep showing this to you because eventually we will have to do this, okay? But anyways, back over here, anytime you know the hypotenuse in a 45, 45, 90 triangle, you take the hypotenuse divided by the square root of 2, and you will have the length of one of the legs, okay? Alright, moving on. Okay, we're moving on now to numbers 31 through 34. I'm going to write down what I should have had, what I should have taken a picture of. Letter A says if x equals 4. Okay, letter A says if x equals 4 and y equals 3, then c equals 5. Okay, they give that to you. And then they say for B, they say x, if x is not equal 4, then y does not equal 3. Okay, they give that to you. And then C is y equals 3. Okay. Now, there we go. Okay, number 31. Let me copy this, guys, so we can pull this over from page to page. Okay, there we go. Okay. Alright. Write the contrapositive of B. Now let's review. The contrapositive, converse of B would be to just swap your if and then. But contrapositive is you swap your if and then, but you also negate them. So the answer would be you would put if, and you put this part first, only you negate it. So it says if y does not equal 3, so I'm going to change that. If y equals 3, then you pick up this part and put it in the thin part, then, and you have to negate it. So x does not equal 4, we put x equals 4. So remember, anytime this is true, and we're assuming all 3 of these are true, it says to assume that in the directions. So if all 3 of these are true, their contrapositives are always true also, okay? So this is also true. So we can add this now to our list of things over here, okay? Anytime you write a contrapositive, it is assumed to be true, okay? So I'm going to copy this, and let's continue on. So we wrote the contrapositive of B, okay? Now, write the converse of A, the converse. So we're just going to turn these two around, okay? If Z equals 5, then x equals 4 and y equals 3. Okay, that's called the converse. Okay, we just took the if and the then part and we swapped them. Alright, okay, moving on to number 33. If y does not equal 3, does it follow that x equals 4? Well, guys, no. I mean, let's go back a page right here. Well, that's not it. I was looking for the converse. But if y does not equal 3, does it follow that y equals 4? Nowhere are you going to find that supported over here, guys. whatsoever. I mean, nowhere. We have if x does not equal 4, then y equals 3, and we have this. Look, guys, we have if y equals 3, x equals 4. We do not have this anywhere, so no, that is not supported, okay? But look at this. Can you conclude that z equals 5? Yes, you can. How, Mr. Earhart? Well, look. Remember, we're assuming all of our given was true. Thus, my contrapositive is true. Look, guys, if x equals 4 and y equals 3, then z equals what? 5. Well, look down here. If y equals 3, then x equals 4. Okay? Well, look what c says. Y equals what? 3. Right here. Right here in front of you. So I'm told that y equals 3. So if y equals 3, then what do I know? X equals 4. And look up here. If x equals 4, which it does, and y equals 3, which it does, then what? Z equals 5. So can you conclude that z equals 5? Most definitely. That's written right there for you. Yes, definitely. Alright, very quickly, college entrance exam things here that we do. Alright, I'm going to shrink this, and you could look in your book, because I'm going to copy these two triangles over, okay? So here's the one right triangle here, and it's a little bigger than the other right triangle, or a little higher, a little taller than the other one, okay? So we have a length of 10 here, and it says BC equals CD, okay? So where's CD at? Okay, so I know this right here, this side equals this side here, okay? I know this is 6 right here. Now, let's see what else we have. I know this angle here is congruent to this angle here, okay? And I know I've got a right angle here and a right angle here, okay? Now, they want us to find the length of BE. They want us to find this little length from here to here, okay? Now, let's stop and think. First of all, do you notice something, students? I have two angles in this triangle, congruent to two angles in this triangle. So I know for sure the two triangles are what we call similar. They are similar, okay? So I can definitely draw a similarity statement. I have AB, C, and I have E, C, D. Now, triangle A, B, C is similar to triangle, okay? A's first, it has no mark. E has no mark. Next is B. B has 1 mark. D has 1 mark, so D comes second. E, D, C would come third. So there's my similar statement, okay? Now, look, side AB right here corresponds with side ED. Do you see that? AB corresponds with ED, okay? And let's see what else we have here. I think we know another length here somewhere. BC equals, yes, here it is right here. Students, my fault. BC equals what? CD. So, no, I've marked that already. Okay, hold on 1 second here. Okay, students, I'm going to have to find BC very quickly here, and I can do that using Pythagorean's theorem, okay? So, we've done Pythagorean's theorem so many times, guys. Please trust me. If you use Pythagorean's theorem, you will get 8 for this side here. Now, if you want to work it out, please feel free to. Leg squared, which is a 6, plus x squared equals your hypotenuse squared. Square it, do all of your work, you'll get 8, trust me. So if BC is 8, then CD is also 8, okay? So now we're ready to go ahead and set up some proportions. And what they want us to do here is that, look guys, they want to know the length of BE, this little segment from here to here. Got it? So, all I have to do, students, think about it, is find the length of EC. Let's just pretend that EC is 6. Well, if this whole side here is 8, and this much is 6, then this little bit right here would have to be 2, because you would take 8 minus 6. So that's our goal. We're going to try to find the length of EC, okay? So what do we got here? Let's go ahead and line some things up here. We have, AB corresponds with ED. I'm trying to solve for EC, so EC corresponds with AC. So I'm going to say AC is 6 over EC, okay? So AC goes with EC. So So 6 over EC equals, and what do we have here? We have to have one side over here matching this side over here. BC goes with DC, so 8 over 8. So obviously EC has to be 6. Guys, look, 6 over something equals 8 over 8. Well, it's got to be 6 because 6 over 6 is 1. 8 over 8 is 1. 1 equals 1. Now, if you don't like that, then go ahead and cross multiply. It's fine. 8 times EC is 8EC, and 6 times 8 is 48, and now divide both sides by 8, and you'll get 6. So EC equals 6, so I kind of guessed at that, and I was right. So if this whole length here is 8, and this much is 6, that means from here to here is 6, then this little bit up here has to be 2, so the answer is 2, okay? Alright, number 36. Okay, now guys, look at this. Please use common sense, okay? Pretend I have a right triangle. That's 45. 45. Got it? That means this side here is going to be equal to this side here. My two legs, like we'll say it's a 5 and a 5, okay? Now, if I lowered this side here and made it smaller, like a 3, what would the triangle look like? What would look like this? This side over here would get smaller down to this. Got it? So this would be a 3. This would be a 5. Did this angle, when I took this line right here and smashed it down and made this side smaller, did this angle get bigger right here or smaller? Well, it got smaller, guys, so it had to be smaller than 45. Whereas this angle here had to get bigger, because if this is 90 and this angle got smaller than 45, then this angle has to be bigger than 45. So now look up here, guys. Your x is across from the, angle x is across from the bigger side. So yes, it has to be greater than 45, okay? So in a right triangle, when your two legs are different lengths, the angle across from the longer leg will be greater than 45, and the side and the angle across from the smaller side will be less than 45. Okay, so I'm going to show you again. I had 45, 45, 90 triangle. That means both legs are congruent, 5 and 5. If I smash this side down, that means this side here has to rotate down. This angle is going to get smaller, okay? So the angle across from the smaller side is going to be less than 45. The angle across from the larger side, the larger leg, is going to be greater than 45, okay? Alright, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.